Now let's take a look at disjunction. When we disjoin two atomic sentences, we bring them together with the word or one of several words that have the same force, such as unless and either or. Suppose we wanted to disjoin Walter eats bread with Charles reads books. We've already symbolized these two atomic sentences with B and C, respectively. So if we want to disjoin them, we simply insert the symbol for disjunction, the wedge or V, between the two disjuncts, and we get B wedge C, which we can read as either Walter eats bread or Charles reads books. Here's another video from Professor Delaplante that examines the truth table for disjunction. Note the distinction between inclusive and exclusive disjunction.
You form a conjunction when you assert that two or more claims are all true at the same time. You form a disjunction when you assert that at least one of a set of claims is true. We'll look at the logic of disjunctive claims in this video. You form a disjunction by saying that either one of a set of claims is true. In this case, we've got two claims. John is at the movies and John is at the library. The disjunction asserts that one of these is true. John is either at the movies or he's at the library. The individual claims that make up a disjunction are called the disjuncts. So you'd say that in this case, A and B are the disjuncts and the disjunction is the whole claim, A or B. We're interested in when a disjunction as a whole counts as true or false. There are two kinds of cases we need to distinguish. Both the sentences on screen express disjunctions. You can represent these as claims of the form A or B. There's a difference between the sentence on top and the sentence on the bottom. With the sentence on top, both disjuncts can be true at the same time. They're not mutually exclusive. You can define a triangle as a polygon with three sides or as a polygon with three vertices, but both are equally good definitions. With the sentence on the bottom, it's different. A coin toss is either heads or tails. It can't be both. So the or expressed in the bottom sentence is more restrictive than the or expressed in the top sentence. The or on top is called an inclusive or. It includes the case where both disjuncts can be true. The or on the bottom is called an exclusive or. It excludes the case where both disjuncts can be true. When examining arguments that use or, you need to know what kind of or you're dealing with, an inclusive or an exclusive or, because the logic is different. Here are the truth tables for the inclusive or and the exclusive or. With the inclusive or, if either A or B is true, then the disjunction as a whole is true. The only case where it's false is if both A and B are false. The truth table for the exclusive or is exactly the same except for the first row, where both A and B are true. The exclusive or says that A and B can't both be true at the same time. So for this combination, the disjunction is false. You're using an exclusive or when you say things like, the dice rolled either a 6 or a 2, or the door is either open or shut, or I'm either pregnant or I'm not pregnant, or I either passed the course or I failed the course. On the other hand, if a psychic predicts that you will come into some money or meet a significant new person in the next month, that's probably an inclusive or, since they're probably not excluding the possibility that both might happen. But sometimes it's hard to know whether an or is intended to be inclusive or exclusive, and in those cases you might need to ask for clarification if an argument turns on how you read the or.
As with conjunction, disjunction is also commutative. In sentential logic, you may reverse the order of the disjuncts without affecting the truth value of the disjunction. We should also note several other features of disjunction. First, you can use the word unless to form a disjunction, as in, unless it's the weekend, I'm working, which means either it's the weekend or I'm working. Second, we frequently find a disjunction embedded within a negation, such as, James is neither watching TV nor listening to a podcast, which is logically equivalent to saying it is false that either James is watching TV or James is listening to a podcast, which we can easily symbolize as tilde, open parenthesis, W, wedge, L, close parenthesis, using W and L to symbolize our two disjuncts. Note the use of parentheses to define what is being negated. We are negating the disjunction of W and L, not the individual disjuncts. The main sentential connective is the tilde, our symbol for negation. As an aside, the negation of a disjunction, as in it's not the case that either W or L, is logically equivalent to the conjunction of two negation, as in tilde W ampersand tilde L. We obtain this by an application of one of DeMorgan's laws, which are a pair of transformational rules that are both valid rules of inference. They're named after Augustus DeMorgan, the great 19th century British mathematician. Finally, as we learned in the previous video, a disjunction can be used in two ways, either inclusively or exclusively. When a disjunction is inclusive, it simply means that the disjuncts could all be true, as in the statement, "For our Thanksgiving we have turkey, cranberries, stuffing, or mashed potatoes." That is, the disjuncts would not exclude each other. Your plate could include all of these. But when a disjunction is exclusive, the truth of one of the disjuncts excludes the truth of the other, as in the statement, "We will bring him back alive or bring him back dead." We can't bring him back both alive and dead at the same time. That's exclusive disjunction. Ordinarily, we'll opt for the use of inclusive disjunction in sentential logic unless otherwise noted. It's a richer interpretation that allows more combinations. As a result, here's our truth functional rule for disjunction. A disjunction is true if and only if at least one of its component disjuncts is true.